Hi, a very good afternoon to everyone. I'm Elizabeth. This is my colleague Stacey, and we are from the Geospatial Information section of HDB. We're here today to introduce you to HDB, to how geospatial and especially geospatial data enables our work, and to take you through in broad strokes the project that Singapore has given us the Geo Innovation Award for. So HDB, I think, is a familiar name to most of you. But for the broader audience out there, I wanted to give some context to who we are. So on screen is our vision and mission. As Singapore's housing authority, our driving mission is to provide affordable, quality housing coupled with great living environments that will allow our citizens living in our towns to thrive. So as an organization, we have a long history. I think earlier on, Joe was talking about this year is Singapore's 60th birthday. But yes, HDB was established in 1960, even before Singapore gained independence in 1965. We were formed to address Singapore's housing crisis, as then many people lived in unhygienic and crowded slums. So we tackled housing shortages, cleanliness issues, and fire issues. The flats back then were basic and functional for efficiency and cost effectiveness, because back then what we wanted to do was rapidly house a nation. So Toa Payoh, formerly a squatter area, became our first self-sufficient town. A quick caveat here. Queenstown was the first satellite town, but its origins go back to the Singapore Improvement Trust. Toa Payoh was ours from the planning stage. So as more people moved into flats with better living conditions, in the 70s, HDB focused on building more facilities to bring greater convenience to our residents. Ang Mo Kio, Bedok, and Clementi towns were amongst the first few towns developed offering a live, work, play, and learn environment, meaning you can do all these things in your own town, right? To provide a more conducive setting for community interaction, HDB provided facilities and common spaces to serve residents' needs in more intimate clusters. In the 80s to 90s, we continued to evolve, and in tandem with a greater emphasis on community development, we started to develop towns with more stronger characters. Attention was given to the skylines and street architecture, and was used to provide a greater sense of identity in our residents. By the 2000s, besides introducing new housing typologies, HDB explored building taller and more innovatively. Our iconic project, the Pinnacle at Duxton, is Singapore's first 50-story public housing and our tallest development. So as we move past the 2010s, and in the years to come, we have and will continue to introduce fresh design concepts to create a new generation of public housing. New housing areas in Bidadari, Tampines North, and Tengah will capitalize on distinctive characters to provide a unique identity and living experience. So HDB is organized along 3 pillars: building, estates, and corporate. So our building arm is responsible for town planning, for new building designs, as well as innovation and research into construction. They oversee the actual building of our flats and plan out upgrading. So our estates focuses on policy formulation, community engagement, property and land management. So the land surveyors and geospatial, we're situated here. So and our corporate arm, of course, provides the essential support to the rest of the organization in the form of HR, corporate communications, ICT, finance, and other services. So as you know, the real-world problems out there, never so simple. We all have our specializations, but there's plenty of opportunity for officers in all the arms to come together to work on more complex problems. So here's a snapshot, actually, of the scale of our operations. So while HDB is mainly associated with residential housing in many people's minds, we actually do have a broader span. So in addition to residents and flats, we do manage over 800,000 parking lots and over 20,000 shops that house the businesses that provide essential services to our residents. So today at HDB, we have 6 key planning focuses. Through smart urban solutions and innovative technologies, we seek to develop towns that are livable, efficient, sustainable, and safe. To guide the development of smart initiatives, HDB developed a smart town framework, which include applications and services in 5 areas: smart planning, estate, environment, smart living, and smart community. So, Singapore is a garden city, or city in the garden. So in planning HDB towns, we do incorporate an abundance of greenery. These green spaces nestled within our housing precincts bring relief to our urban environment. Where appropriate, water bodies are also interwoven. I think hopefully everybody's familiar with Punggol Waterway, right? So these contribute to biodiversity and add to the recreational features of the town. Collectively, such green spaces form a natural urban ecosystem and allow residents to reconnect with nature. So since 2015, HDB has been introducing a new generation of neighborhood centers, or in more colloquial terms, shopping center. Right. So within these neighborhood centers, residents have easy access to a wide array of commercial facilities. The things we all want, the supermarkets, the food courts, and all the other essential commercial facilities and services. Within our NCs also, community spaces such as sheltered community plazas are provided to encourage residents to get together over daily activities and community events. So somewhat staying on the theme of connection, next we have also mobility and transport. So HDB towns are planned with a comprehensive transport network, road, rail, bus, so that residents can move around their town and other parts of the island. In line with Singapore's aim to become car-light, HDB works with other government agencies to encourage the use of public transport. Pedestrian-friendly footpaths and cycling networks are well linked to the parks and park connectors, promoting walking and cycling, encouraging a healthier lifestyle. And also, back to shared community spaces. They play an important role in promoting social interaction and forging, community bonds. So our new estates are planned with a wide variety of community spaces at varying scales, ranging from town plazas, which I mentioned earlier, to common greens and community living rooms, where residents can hold activities or meet with their neighbors. In existing towns, some of these new spaces will be incorporated when we do remaking of Heartland. So I think also, earlier on in his starting speech, Joe was talking about how much the environment in Singapore can change. Sometimes living here day to day, we may not feel it, but I have friends who are working overseas. Every time they come back, sometimes they look at it and they went, this is not the Tampines I remember. So in trying to build a sense of bonding to where we live, heritage is a very important element that HDB does strive to preserve when we redevelop a town. So where possible, memorable landmarks may be retained, or markers and storyboards introduced to recapture fond memories of a place. Theme playgrounds that reflect the history and the heritage of the area have also been introduced. So considering our broad scope, how has HDB managed to achieve what we have and thrive? And how will we continue to gear up for the future? As an aside, so when I was asked for my bio, I put in a notable number. Notable to me. So what is it, you ask? It's the fact that I've worked in geospatial for nearly 30 years. And this has all been in my time with HDB. So HDB was one of the pioneer adopters of GIS in Singapore together with URA. So this technology has been a part of our fabric for a very long time. Spatial modeling and analysis is an important component of town planning, policy formulation, and estate management processes. I think through all the use cases shared earlier on also, it becomes very clear that visualization of data is a key means of communicating with all our stakeholders, internally, across agencies, and with the public. So map applications have also been a part of our suite of e-services for a while. From our main map website, there's a general map-based e-service that provides location-based information on our properties. In our mobile app too, maps help to orientate users, showing them perhaps what's the nearest car park to their house. Maps have proven to be an ideal means of connecting to residents and providing important information in an easy-to-navigate format. So, one thing, in my 30-year career, I've seen GIS go from a niche technology with very specialized users, sitting in front of really big workstations, retrieving the information they need, to what we see today, where it's broadly available, you have it on your phone, and increasingly it's getting incorporated into many, many areas. But you know, one thing that hasn't changed? Data. The bedrock of everything. Well-defined, timely, and quality data is still the lifeblood of GIS. So I think anyone who has worked on the creation and maintenance of geospatial data knows that it can be quite resource-intensive at times. So every set of data we maintain should be curated to serve many users. As mentioned, a well-defined data set where, let's say, for example, our HDB building data set, where we've consulted users and we have a general idea of what they need. It can then be used for multiple use cases. For environmental analysis, where the layout and typology of blocks can be used to analyze wind flow. For real estate and property management, where block location can inform analysis of market trends, property values, and where location and other key operational attributes, something like perhaps the building age, can help in the planning of upgrading. So as the operating environment out there becomes more complex and the demand for more data is growing, at the same time, our workforce is projected to decrease in the coming years. To prepare for the future, it is crucial to identify and implement strategies that will enhance operational efficiency in our data pipelines. So as I mentioned, data is the core of GIS. It's an important enabler both to HDB and to the wider government. Better data will help us plan for the future, for inclusiveness, for aging, and for any one of many potential future challenges. So within HDB, we actually have been looking at this problem or this challenge for a while. We have been constantly studying different ways of reducing manual processes. From the initial point, where we create data from different sources, be it BIM, CAD, imagery, whatever, right, to the downstream data quality checks. We are constantly researching better and more efficient ways to do both. Which brings us to this awarded project. I'll hand over the presentation now to Stacey, who will take you through how we use Esri's technology to improve our QC process. Stacey, please.
All right, thank you very much, Liz. So now I will start by giving an overview of what a data validation process can look like. The data that we have in question is captured at the design stage and at the as-built stage of developments. For those who are not in the architecture, engineering, and construction sector, the design stage is before construction takes place, but when all the project's qualified personnel have agreed on how it should proceed. After construction has been completed, the actual live implementation of the final product on the ground is what we would call the as-built stage. Data is captured at different stages for different purposes, and it all comes down to what the needs of the data user are. Sometimes the data user isn't able to wait until construction has been completed, so then they will need the first version of the building outlines available. At whichever stage of development data is needed, data needs to be processed to make sure they fit into the format and the system appropriate for the user, and also to ensure that the information is accurate and reliable. In an ideal scenario, what we receive from data providers would be 100% clean, but the reality is often more complex, and data quality isn't always within our direct control. Despite multiple checkpoints in the process, discrepancies can still emerge. And this is why it is important to implement our own robust validation process and error detection mechanism. By doing so, we ensure the integrity of our data regardless of its source, and we maintain the highest standards essential for our work. Then now I will walk you guys through what conventional validation can look like with a very simple example. What we have here is a set of building outlines, and for the purpose of this presentation, it has been simplified, cleansed, and made hypothetical to avoid getting anyone into trouble. And while there are many other data sets that we process, we chose HDB's building outlines as it is the most tangible set of data. On the screen here, you can see the blue polygons, which are from the design stage, and they have already been processed and deemed to be accurate and reliable information. It has several attributes, such as the street codes and the block numbers and postal codes. And then a couple years pass by, and construction is completed. We then send surveyors down to collect the latest information on our building outlines, and then we would receive the yellow polygon shown here. What we would have to do is to look out for geometrical differences between the as-built building outlines and the design stage outlines. We also have to check that the block number and the postal code attributes that they match and that there will be no discrepancies. To make it easier to detect the mismatches, we changed the symbology of the polygons, and then we label the attributes. And now the polygons at the design stage are in the black outline, and the red dashed lines are the unprocessed polygons in the as-built stage. This is the scale we would usually be viewing a site layout plan. And upon a closer inspection of the geometry, we can spot the area circled in red, one location where differences occur. And as for the attributes, you would notice in the block circled in yellow that none of the attributes match at all. You can see that the attribute differences highlighted in the tables, that for the design stage, the object ID is 23, for the as-built feature, it's 4, and for the block numbers, one is AAA, 111A, and the other one is 111B. And for the postal codes, one is 6013, and the other one is 6014. And so when none of these attributes match at all, the only way to check for mismatches is through a spatial assessment. So what we have done is to make things easier by scripting an automated workflow that all we would have to do is upload both files and click Run. The script automatically generates a report that prints out exactly what we need to know. In this situation, the report stated that there was one field missing, and then going down to the fourth point, you can see that it has automatically detected through a spatial analysis that 8 of the 19 blocks had input the wrong postal code. Accompanying the written report is this purple shapefile exported called the Building Postal Code Compare. The report lists the 8 polygons that had postal code discrepancies, listing the design stage and as-built stage identification numbers and their respective postal codes. The accompanying shapefile shows you where the postal code discrepancies are, as you can see in the labeled red text. The new shapefile has joined the relevant fields needed for this comparison and has a dedicated field called the postal code check to state if a polygon has a discrepancy or not. And then we can send this report to the data provider to check on the discrepancies before they are amended. The script we wrote also automates a geometric difference analysis to determine how different the polygons are between the design and the as-built stages. Earlier on, we saw that we could spot one location where the polygons differ, and now through a combination of ArcPy modules, we have automatically identified 16 locations where geometry differences have occurred. A shapefile named the building geometry difference is exported to show precisely the areas where the polygons don't line up. Additionally, each red area also identifies for us the design stage block number that it is connected to, as well as the feature ID of the as-built polygon. These examples that we've zoomed into here are actually roof details the as-built polygons captured that the design stage polygons did not. So being able to automatically identify and isolate these differences is crucial for maintaining the highest standards of data integrity, without which we risk overlooking critical details that could impact the accuracy and the reliability of our geospatial data. So what I have shared with you today is merely the tip of the iceberg, and the future of automation holds immense potential. We can extend various other combinations of functions to other attributes and and to other attributes and geometries, and then we can scale vertically within a single data set. We can also apply similar processes to be adapted to other data sets so that we can scale horizontally across multiple data sets. These processes can also be shared and implemented with data providers and other data processors to streamline operations along the different points of a data set's life cycle. I'm excited to see where we can take these concepts in the future, and we look forward to any questions or thoughts that you may have. Thank you.